Alright, welcome to week 3. So by now you should be a little more comfortable with doing some basic data analyses and using R Markdown to report on these analyses. You should be able to read a data set into R from wherever you've stored it on your computer, and you should be able to do some wrangling, some cleaning, and some visualizing of that data set. So this week, I just want to get a little more complicated with that wrangling process. I want to talk to you about situations where data comes to you in a form that isn't quite what you need for the analysis you want to do. And then we'll talk about some special data types that are a bit more high maintenance and require some special attention. So let's start out with this notion of reshaping. To illustrate this, we'll use that serials data set that you used last week. You probably had this downloaded in a markdown that I gave you called practice.rmd. If not, you can download the data set and read that into your R Markdown file. That's fine too. The package that we're going to use for some of these reshaping tricks is called tidyr. This one loads and installs with the tidyverse. So if you're already installing and loading the tidyverse, you don't have to do anything different. All these functions will already be available to you. Now notice in this serials data set, the way that it's set up is for each serial, we have many columns measuring each nutritional item. So we had a column for the amount of calories in that cereal, a column for the amount of sugar, and so on. So suppose you said to yourself, well, I would like to make a plot comparing these measures. I would like some box plots showing me how many calories there are versus sugar versus protein, etc. in all of these cereals. And so you know already how to use ggplot, and you say to yourself, okay, the first argument is cereals, great, I can do that. And then you set about defining the aesthetic. And what do you want on the x-axis here? Well, in principle, you want that x-axis to be labels for all of those nutritional values. But we can't do x equals calories because then we just have calories. And we can't do x equals sugar because then we just have sugar. And anyways, these are numeric variables, not categorical, so they don't really make sense to be on that x-axis for side-by-side vertical box plots. So we're sort of stuck, and we're sitting here saying, I know what I want to make, but I don't quite have the data in the form that I need to send that into my grammar of graphics. So here is the main concept that maybe will underlie some of this reshaping, and that idea is what's called tidy data. In fact, this is the source of that name, tidyverse, for the suite of packages that we've been using. And it's very simple. If data is tidy, then what we have is we have columns that measure variables, and then we have rows that represent observations. Maybe these are subjects in a study, like people. Maybe these are cereals. These are each of our units of observation. And then the cells within the data set, those are the values. So we have a value for a certain variable observed for a certain observational unit. And this hopefully feels very natural to you, and it's surprising how often you will see data that actually isn't in tidy form and needs to be tidied. And so I want you to keep this in mind. What are your variables? What are your units? And depending on your analysis, what you think of as your variables might shift a little bit. So let me show you what happens. So I have this idea that I want to make side-by-side box plots. So let's think about that penguin data set again, where we've measured various dimensions of the bills of these penguins. And so I'm trying to make a ggplot with these penguins, and I've put the aesthetic that I would like to be able to use. What I think I want to do is I want to have on the x-axis the bill dimension, whether it's the length or the depth of that bill. And then on the y-axis I want the size. And I want the number of millimeters that that bill dimension is measured to be. And then I've decided I want to color it by species so I can compare these penguins. And now here's what happens when I try to make a box plot with that aesthetic. Of course, it breaks. We've got a totally blank plot here. And it says error, bill dimension not found. Now if you recall, you can go back and look, or you can check out the data yourself. That penguins data set did not have a variable called bill dimension. What did that data set have instead? So this is tip number 1. I think thinking about these data sets is a little tricky. It requires some shifts in your natural thinking. So here's my first tip of the day. My first tip is to work backwards from your end goal. So if you are trying to make a visualization, or if you're trying to do a certain hypothesis test or a certain summary statistic, ask yourself, what line of code would you like to be writing at the very end? And so that's what I've done here. I've said what I really want to do is I want to make the x aesthetic be bill dimension and the y aesthetic be the size. Even though those variables don't right now exist in my data set, that's what I would like to have in the end of my process. So now I've defined my end goal. So let's take a look at this data frame. So here we have our penguins data frame, and we can see that none of these variables is called bill dimension. We do have bill length and bill depth, and we have numbers for each of these. So I have to ask myself, how could I morph this data set? How could I reshape this data set in order to have the same information, but formatted with bill dimension and size as two different variables that I can put into an aesthetic? So my second tip of the day, and this is my favorite thing to say in almost any class, is draw a picture. I literally mean not just draw a picture of the plot you're trying to make, draw a picture of the data set that you are trying to create. Draw a picture of what form you would like that data to be in so that you can get to your end goal final step. So now that we know what we're aiming for, now that we have an idea of what our variables are in that tidy data set and what information they contain, now I can think about using code to achieve that. So in this case, the function I want to use is called pivot longer. So I'm taking my data frame, which currently is wide. It has the dimensions of the bill as different variables. And I'm going to pivot that thing to be long, so that now I have each dimension listed with its corresponding size. So the original variables that I wanted to take from wide to long, we can see right here. Those were bill length and bill depth. Now you could pivot more than two variables. In this example, it's just two. And then we say, all right, what am I going to do with that information? Well, I want to take those original variable names and store them in a new long column called bill dimension. So that's that first argument here, names to bill dimension. And we can see in the final product, that's what happened. Here's a column called bill dimension, and it has bill length, bill depth, bill length, bill depth. This is a categorical variable saying which dimension I am currently measuring. And then I said, well, what do I want to do with those original measurements of length and depth? Where do I want to put those values? I want to put those values in a column called size. So here I have for the first penguin, we have some demographic information, and then we see that the bill length of that particular male Adelie penguin from Torgerson was 39.1 millimeters. And for the exact same penguin, so he's listed twice, that bill depth is 18.7. So now instead of each penguin being listed once, we've got them listed twice. It's kind of a long data set. Our idea of observations has changed a little bit. Now it's not that each row is a penguin, it's that each row is a bill dimension of a penguin. But other than that, it's the exact same information. It has just been morphed into a different shape for the data set. And so now that we have the data set looking how we want it, that original code, that aspirational ggplot code, will produce a picture like this. We've got our bill dimension on the x-axis, our size on the y-axis. So now these two bill dimensions, depth and length, have been separated. And then we have box plots colored by each of the three species. And this gives us some takeaway message. We can see here that this Adelie species maybe has a slightly shorter bill, but not necessarily a shallower bill. The shallower bill is the Gen 2 penguin. And so if you know a little bit about penguins, I suppose, this might give you a better idea of what's going on with these species. We have reshaped our data so that we can make the visualization that was our end goal for the analysis. Now I want to let you know about something really quickly. This pivot longer function is a little new. It came about maybe 6 months ago. This function used to be called gather. So if you see old code that uses the word gather, or maybe if you have an older version of tidyr installed, you may be more familiar with gather. And that's okay. I think the pivot longer function is a bit clearer and easier to use personally. I do suggest that you reinstall tidyr in order to update that package and get this new version, pivot longer. But don't get too confused. If you see gather, same idea. It is reshaping the data to be longer instead of wider. So this is your chance to try this out on your serials data set. So I want you to create a new data set. Let's call it serials 3 since we did 1 and 2 last week. And what I want is the name of the serial, and then I want a column called nutrient, and I want a column called amount. And you can narrow this down to just protein, fat, and fiber. I don't need all of the nutrients to be pivoted. So see if you can apply what you just learned in order to take that wide serial data with so many nutrients listed as columns and make it a long data set with these two variables, nutrient and amount. I'll give you a moment to do that. Okay, So hopefully you took a minute and tried that out and hopefully successfully pivoted your data. If you're one of those people who's not pausing the video and trying these things, really you're just hurting yourself. So I really recommend that you take a moment, pause, and actually try this out. It's not enough to look at code. You need to learn by doing. You need to type your own code. But regardless, let's move along. Now you might say to yourself, okay, if I can take a data set that's wide and make it long, surely I can take a data set that's long and make it wide. And of course you'd be right. That function, as you might guess, is called pivot wider. And now instead of taking variable names and sending them to a column, we're taking an existing column, hopefully one that has a categorical variable that has words, and sending those to be new column names. So here we have our three species, Adelie, Gentoo, and Chinstrap. And what we'd like to do is take this data frame that has one column called species with those three categories and turn it into three separate columns. And then what do we want to put in each of those columns? Well, in this case, I've chosen the variable body mass. So what I'd like each of those columns to have is the body mass of that penguin. Now this looks like this code should work, but instead we get this strange warning here. And R tries to do its best. Remember that a warning's not an error. It says I tried to run this code. But what it gives you here is this strange looking data frame where the Adelie column contains within the column a list. So each element of that variable is itself a list. And so we've got one list for Adelie, one for Gentoo, one for Chinstrap. It's strange, it's unhelpful, you probably don't know how to work with this data. What's going on here is that when we pivot wider, we need a column that identifies the individual penguins. There's a nice shortcut function for this in the tidyverse, row ID to column. There are many other ways to create this column if it doesn't exist. And so here what I've added on is not just the demographic information of each penguin, but I've given each penguin a label, just a number 1 through, 344. And why this is necessary is because then when we pivot wider, we can keep track of which values in the new columns corresponded to which penguin. So this leads me to my tip number 3 for thinking about reshaping, which is to separate your task into bite-sized steps. It can be very easy to think of your end goal, work hard, figure out that end goal, and then try to do everything all in one blow. This is difficult for troubleshooting, and this is difficult for making nice pipelines. So I want to encourage you to do what's called decomposition, to take your task and write it out as bite-sized steps. In this case, my steps were create an identifying column, then pivot the data, and then maybe I visualize or analyze the data. And so in this case, this is what the pipes are great for. I'll go through that first process of adding the row ID to column. I don't have to save that new variable into the data set. Notice here I didn't update the penguins data set at all, because I don't really need that new variable to always be there. I'm just using it for this pivoting process. And then I take that result, and now I pipe it into pivot wider, and there we go, we have pivoted wider. And so we've said, here's penguin number 1. Penguin number 1 is Adelie, so we have its body mass in the Adelie column. And penguin number 1 is not a Gentoo or Chinstrap penguin, and so this just fills in with NAs. So let's try this out on some data where pivoting wider makes a little more sense than the penguins data. In your cereals data set, you have a variable that tells you which shelf that cereal was placed on, 1, 2, or 3. And I'm interested to know, do these cereal placements correspond to different nutritional values? For example, maybe a very sugary cereal that's marketed towards children might be placed on a lower shelf so the kids will see it. So I want you to make a new data set. We'll call it very creatively Cereals 4. And I want 4 columns. I want you to give me the name of the manufacturer. I want you to give me the average amount of sugar for cereals from that manufacturer on shelf 1. That was a lot of qualifiers. The second column is the mean amount of sugar among all cereals in that manufacturer who were put on shelf 2. This is going to take you several steps. Your hint here is you definitely will need to use group by and summarize at one of the steps. But I want you to try those tips I gave you. I want you to draw out the data set that is your final product, what it might look like, make up some values, fill in some manufacturers. And then I want you to decompose that into the steps that you will need to reach that final product. There are a few of them.